All right, we're going to start a new unit, electron, energy, and light. And so right now I'm in the storeroom and it's dark for a reason. And so we need to understand light in general. So I have this contraption, one of these plasma globes, and this is the Google Doc that you should have with you as you're watching this video. We would do this if you were in person, but since we can't do that this year, this lights up when I give it energy. And there's different forms of energy, and we won't get into the details, but if there's no energy, then this does not light up. Okay, so we have energy. It is plugged into an electrical outlet, so therefore that can help out with question number one: what is needed in order for an LED, or what is needed for a light bulb to produce light? So if you have a light bulb in your house, what do you need in order for it to produce the light? And that would be the answer that I'm asking for in question number one. Now, at the top of your paper, we have information about how to hold the energy stick. So we're on the energy stick, and this device right here is the energy stick. Okay, when it has energy, it lights up. There are three LEDs. There is a red LED, a green LED, and then a purple LED. It's maybe very difficult to see. The red is, as you're looking at the screen, on the right, the green is on the left, and then the purple or blue is in the middle, and it is very difficult to see that, but we have a couple different things that'll show that. So anyway, the instructions at the top, a little confusing, so ignore it. I'm gonna do what I'm asking you to do, and I'm gonna take the energy stick. Now the energy stick it needs energy because these are LEDs, and let me show you this. So if I turn off the globe, this energy stick does not light up until I give it energy. And so I give it energy, and we can see the LEDs. I flip-flopped it anyway. Let's turn it back to where I had it. You can see that there's a faint blue color there in the center, and you're gonna have to focus quickly or closely to see that. All right, so the instructions are, I'm gonna hold this and I'm gonna point this energy stick towards the plasma globe. Now the plasma globe is producing light, but we're just gonna say the plasma globe is energy. And energy is what is needed to light up a light bulb. And so I'm gonna move the energy stick closer to you can't even see that. I have to turn my screen. Sorry, hang on here. All right, so I'm moving the energy stick towards the plasma globe. All right, we see that I'm a pretty good distance. I'm about maybe 2 feet away from, and we see that a color is being produced. I ask you on the paper, do all the lights light up at the same time when I move the energy stick towards the globe? And if they do, record that, and if they don't, record that also. And if they don't, move this just a little bit more, sorry about that. This is going to be highly bad, but I'm making it in one shot. So we see only one of the three LEDs being lit up. And I'm, again, about 2 feet from. There's nothing in between the energy stick and the plasma globe. I'm gonna move it closer to the plasma globe, and we notice that another LED has lit up. So I think I ask you to record the order of how these light up when they get closer to the energy. So greater distance away means less energy needed to light the light bulb up. Moving closer means more energy. And as I move closer and closer and closer to the plasma globe, I'm almost, and it's hard to tell, I'm sorry for this one not being that great. There's just a faint little blue color, and I'm pretty much touching the globe. Okay, but I'm gonna go reverse. I see a red, I see a green, and I see a blue. Notice how they turn off. They turn on. This one's first, this one's second, and then that one's third. And then they go in reverse: blue, green, red. Okay. So this is showing you that different colors have different energies, and further away requires less energy to light up. Closer to needs more energy. All right. I'm just gonna touch the plasma globe for coolness. It's really cool. All right, so we're gonna turn to the other side of the paper. Well, I guess you can't turn to it. You're gonna scroll to page number 2, called Energy of a Photon. All right, so we should be on the other side, and this one may be a little bit better as far as the energy stick. The energy stick is one of those you have to be there to really see it. But in order to light a light bulb up, we need energy. Now we will focus more on what causes the light that we see, and we are looking at it with only our eyes, in which the human eyes can only detect visible light, which means we can only see visible colors, and other things are outside of our spectrum. So what you see on the screen is a circuit board, and we have 1, 2, 3, 4 light bulbs on the circuit board. And I'm going to give the light bulbs energy with this generator, and you're going to hear it being turned, and it's going to make an annoying sound, but I have to give light bulbs energy in order for them to work. So I'm going to turn the lights off. There's no energy, therefore there's no light. So I'm going to give, and you can listen to the generator. Low and slow, little energy. So I don't have a whole lot of energy that I'm producing right now. But right now I have enough, and it should be very similar to the energy stick and how that they produce their light. Now I'm turning this generator very slow, but I have enough energy to produce a certain color. And I believe I'm asking you about the order in which that they light up and which one lights up first. But we're all about which one's lighting up first, and is the energy that is needed to light up that light bulb, is it a high amount of energy or a low amount of energy? I'm going to speed up. When I speed up, that means increase energy. And we notice that we see a second color light up. And that would be, it looks like a green color. I'm going to give it more energy. You can see that they're glowing brighter because more energy, more light. And then when I get enough energy, I see a third LED light bulb light up. So I'm going to let it go, and I've stopped the generator, but it still spins, but we're watching how it goes when they turn off. Now as I have less spins, I have less energy. And then what color was the last to stop producing light? Which one's the first?